Hi, I'm your host, Gideon Rubin, and this is the Data Standard Podcast Experience. We're really excited today. On our show is Derek Singh, Chief Analytics Officer at Fixed Hub. Today, we're speaking about data modeling in the fixed income space. Welcome to the show.
Thanks, Gideon. I'm happy to be here.
Great. I'd love to hear a little bit more about, your background. Starting honestly with academia. I'd love to hear a little bit about kind of how you got to where you are.
Sure, Gideon. So, I've been working in the industry, financial banking industry for the past almost 25 years now, and I've been pursuing my academic studies throughout. I would say in retrospect, it's much more difficult to do that way. I would recommend people try to front load their academic studies as much as possible because there's other things to consider when you work. Having said that, I've completed 2 master's degrees, one in applied mathematics from the University of Washington, a second in applied statistics from Penn State University. Both of those completed while I was working for different in industry for Wells Fargo most of that time. And I recently finished my PhD in operations research at the University of Minnesota last year. That was while working as an executive in the quant modeling team at US Bank, based in Minneapolis, Minnesota.
Wow, that's you definitely have a strong academic background. It's interesting. I also have a master's in applied statistics. I found that so interesting. And I actually thought about going on to potentially do a PhD or another master's as well. That once you get into, for me at least, once I got into applied statistics, things like econometrics and things like that became super interesting.
Yeah, I mean, it's good. That's I can lead off of that. I think the deeper you get into a STEM discipline, you start to see things at a deeper level and really appreciate the power of it. One of the phrases I like to no disrespect to undergraduates, is that you don't quite know what you don't know. I view education as a continuous process. It's a lifelong process. I don't know that it ever really ends. But one becomes more aware of what you don't know, the further and deeper you get into a particular subject. And that spurs new and interesting questions and new areas of research, which it's just what I would recommend. What I see as the main value in getting a PhD is it equips you to do your research and sort of gives you the skills and trains you to formulate good questions and then research how to, the answers to those questions. I think prior to doing the PhD, I'm naturally inquisitive, perhaps most people are, but I wasn't quite equipped skill-wise, even with the master's, to really get deep and answer my questions. I typically need some help, or some advice or counsel from someone with more in-depth training and research. So I really think that's the value in doing the PhD, is it, equips you and trains you to learn how to ask good questions and answer those questions, which in turn leads to more good questions, right? Scientific method at work.
Yeah, that's interesting. So when you, while you were working and doing your academic training, was there frustration on the, so for me, you do something in academia and you like modeling or something, and you get all the data, you put it all together, and then you get a result. In the business world, you don't always have, the reality is you don't always have all the, or you don't have the ability to get all the data, or there are all these other challenges. I'd love to hear from you some of those experiences or how you feel about that.
Sure. I mean, you could liken it to, I think of working in the quote real world, for lack of a better term, as engineering, right? Like if someone says to you, hey, we need to build a bridge. Well, you don't get to choose. Like you said, a lot of the decisions are already made for you, like budget, materials, timeline. So you got to do the best with what you got, and this can be very hard and very challenging for a number of reasons, where if you go to someone in the mechanical engineering department, they may just reject the problem or just tell you the problem is ill-defined. You know what I mean? Like mathematicians love to say that this problem is not well posed and then just move on. But we don't have that luxury in the real world. You can't just move on. That is the project. So I tend to think of it as wearing different hats. Like I'm very scrappy when I do work in the real world. And if you have the benefit of time and luxury, I'll put on a different hat. and put on like my PhD hat or my research hat, say, let me take a step back and think about this problem a little bit more from a higher viewpoint, if you will. Like, if the problem is ill posed, how can we define it in such a way that we can employ some more in-depth academic knowledge and theoretical power to it? So case in point is like, the last few projects I worked on, pretty much any project. So I joined, I've been working for Fixed Hub for the last year or so, but due to and we specialize in fixed income proprietary analytics. We're a small firm. We're building some indexes to help map out, create transparency and clarity in the corporate bond market, which is typically known to professionals, but not so well known, let's say, to people that don't really actively trade or invest and make corporate bond investments. So we're trying to improve the transparency there. But again, it's a case of work with what you got. I originally was a consultant for this firm. I recently joined as an executive for the last several months now. I've been building out their MVP for the last several months, and we're up at the point of going to market now. But due to some transition in staff, I had to sort of relearn a lot of the basics and a lot of fundamentals for how we do things and fix things. And so we're at the MVP stage now, but I'd like to step things up and use some more sophisticated machine learning constructs for the next iteration, let's say for 2022.
Nice. And when you're looking at challenges, both where you are now, but just in general, what are some of the main challenges to sort of executing all the way through and actually having something of value?
Yeah, so it's good that you mentioned that. I think of it as striking a balance, right? Finding a compromise, and a lot of that depends on one's own individual background and level of expertise. So if you say you come primarily from an industry-based background, you may be comfortable with a more of an engineering approach, like you said. Like you work with what you got, you test it, you back test it. If it's good enough, it works. You call that iteration of the product done, and you move on. So very practical focus. But someone like my advisor or a lot of academics, like I said, will either just refuse to work on the problem, or will say, well, you need to get me all my requirements before I really lift a pencil, lift my hand to work on it. So that's these are the two different extremes. What I like to try to do is strike a balance between the two. And again, that depends where on the scale your own skill set is. For different people, the balance will be at different points in the spectrum. But for me, I try to find a balance between theory and practice and make that work. At the end of the day, we're solving constrained optimization problems. We have very real world constraints, budget constraints, time constraints, resource constraints. So in optimization, at a minimum, you need a feasible solution. What that means is a solution that can satisfy all the constraints. So that's really the approach I tend to take, is strike a balance, at least come up with a feasible solution that gives a decent result, but then try to improve on that solution as best we can, using what we know from both theory and practice.
Yeah, that makes sense. It's always, I always used to tell people, you've done a lot of what I aspire to as far as continuing your academic career while you're working. I always tell people I'd love to be a full-time student. And one of the reasons is exactly what you're saying, because, the theory is super interesting and getting into it and being able to solve the problem. Whereas in the real world, you take the theory and you might not have all the elements you need to solve the problem. So you have to kind of make do, and hopefully it's an improvement and it adds value, right?
Exactly. And, the two can complement each other. And another thing that I find also, having managed big teams, is it helps to have people from diverse backgrounds. That really can help quite a bit. To your point about statistics, we hired a tenured professor from statistics at one of the Minnesota universities, and he was really a strong addition to our team. We did, this was at US Bank when I was in Minnesota, we do a lot of econometric modeling, and we answer to the federal government. The federal government has a lot of regulators with deep economic and econometric backgrounds from Ivy League institutions, and they love that stuff. They love talking on the theory side of things. But us, the workers in the field, we're subject to all these other constraints, right? But it does help to have that bench strength and that depth on the theory, because the government, our regulators, they really appreciate that. They're concerned about your solutions from a practical perspective. We need things to work and make sense, and we need to worry about things like bias, right? To make sure, like fair lending, for example, we're not discriminating against certain customer segments. Those things are very important. So the practical side of things matters, but they also want to know that you actually know what you're doing and you understand what you're doing from a theoretical perspective, right? Which, if you don't have that strength of talent on your team, again, it's hard to know what you don't know.
Yeah. And so tell us a little bit about what's the value you provide in your current, company? What's the value you provide in, like, who's it being provided to? Like, who's actually getting the benefit of the modeling that you're doing?
Yeah, so I mean, we're in a very dynamic space. Our customers, potential customers, are really hedge funds, asset managers, institutional investors that may have experience in other financial fixed income markets or equity markets, but don't necessarily have a lot of experience in the corporate bond market. And so, what we're trying to do is to come up with a set of more transparent indices that help investors track certain segments of the market, like energy and oil, financials, utilities, corporate cyclicals, non-cyclicals, and different rating segments. So they can see where the market is trading. Only 20% of the market is liquid in the corporate bond market. It's a vast market, almost the size of the US Treasury market, enormous in size, a lot of volume. But it's a case of, like, there's so much data and there's so many dimensions to the data. It's hard to reduce the dimensionality of the data into, let's call it, the key dimensions, the principal dimensions that matter, and then extract and build what we call cohort curves or indices to help you understand how is the market trading in these different segments relative to each other, and then also relative to the other markets, like the US Treasury market, or even the equity markets, the stock markets as well, or municipal bond markets, things like that.
So are your customers paying for the models, or they're paying for the index that you're building?
It's a lot. I mean, there's different revenue-based models. The main model, if you will, is what we call the license-based model. So they'll pay for access to our cohort curves, which are essentially like indices on a periodic basis, typically an annual basis, and they'll pay a flat fee for that. And for that, they can get end of day curves. They can also get real-time curves, so we can see how the market is trading intraday. A host of other analytics beyond just the yield curves and the spread curves, like Bollinger Bands, equity type analytics, Z-scores, so you can see, like, on a normalized basis how the individual bonds are trading, but also the bond cohort, the indexes are trading. We also have historical data sets, which we provide under a different for a different fee, under a different revenue, different agreement, so they can see, like, how did the market react under COVID, which is a favorite question we get.
Oh, nice. It's so interesting, the COVID data, because what we've seen too is the typical scenario is more of like ad hoc data science. So you do a bunch of analysis, you build a model, and then the model's running. And then if you need a new model, you have to go back to training and rebuild it. But when COVID happened, the data was all new. So it didn't really have a fit to anything any of us have seen out there. Have you been able to tell yet if sort of the modeling you were doing during COVID is going to be I guess, useful again in another sort of, like, I don't want to call it catastrophic scenario, but sort of like massive, sort of impactful scenario to the markets?
Like you said, I think what the benefit of having COVID in our historical data sets is it helps train the models on outlier events, right? So no doubt that's been helpful. It's hard to say, what's an outlier that has already happened, in some sense, is no longer an outlier, if you will. You know what I mean?
Yeah.
And so it's difficult to say, is my view on how does this help us with, the next unknown. But it is incorporated into the data set, so that now becomes describable phenomenon. That's the way I tend to think about it.
Yeah, the good old black swan scenario, right?
Yeah, I mean, it's interesting you mentioned that, because on a separate topic, my dissertation is on this notion of known versus unknown data, and how do you make optimal decisions based on different concepts of uncertainty. Perhaps we could talk about another time. But very briefly, the notion is around, if you think about a lot of classical fixed income mathematics, portfolio optimization and whatnot, we tend to represent what we don't know through a probability distribution, right? Like, I do some historical analysis. I see that, stock returns for a certain class of equities, tech equities, maybe, have a certain type of skew, certain types of volatility and skew, and I estimate those components and I fit a distribution to it. What I did in my dissertation was say, well, that distribution itself is an assumption, right? That itself should have uncertainty around it. So what if I create a family of distributions around a so-called reference distribution, which is purely driven by the historical data? So I have uncertainty around the distribution of outcomes itself. How does that degree of uncertainty impact my optimal decision-making and my target returns, for example, or losses?
Yeah, that's interesting. I mean, once you do that, I can see how if you can figure out, because you're sort of shifting what model you're going to lock it to, so to speak. So then
Exactly.
you can sort of be more open to kind of refitting as things are evolving.
Yeah, there's many ways of thinking about this. I like to think of it as in terms of game theory, like a two-player game. If my job, let's say I'm a portfolio manager at BlackRock or one of these big institutions, then my job is to, rebalance the portfolio for from now until the end of the year, for example, right? And there's all kinds of risks that could happen, like political risk, energy prices, you name it, right? Stock market drops, but I make some assumptions in it. And I can also think of the market as my adversary. And so that's how I think about things in my dissertation. You can loosely think of it as I give a certain amount of power to my adversary. And my job is to still rebalance my portfolio to match target, improve returns as much as possible, or reduce losses as much as possible, or a mix of the two. But the market has a certain level of power P, and it can distort whatever, the current state of the world, if you will, using that power level P against me to the best of its ability. So you can kind of think of it like a prisoner's dilemma kind of problem or something like that. So it's an interesting way to think of it.
You're starting to remind me of when I was reading, George Soros with some of his concepts of like how you're impacting the market while you're investing in the market. Of course, it's different depending on what size investments and what type of market and everything. But it's people always want the data scientists to predict things, and we all have an impact as we're predicting, but that prediction alone can have an impact, right? So it's very interesting how that sort of plays out in the real world.
Definitely. Yeah.
So I'd love to hear a little more. What are some of the biggest challenges in your industry right now? Some of the things, oftentimes we hear, data access and things like that, but are there, what's really challenging across your industry today?
Man, I would flip it around and say what isn't challenging. I tend to think everything has its level and degree of challenge. Fixed income is always challenging, like you said. Data is definitely one of the big challenges. Like fixed income data is typically much more difficult to access, and it's not freely available. Like equities data, you can get in any number of places or through any number of APIs or subscriptions. Fixed income data doesn't come cheap. It's typically, most of the transactions happen over the counter or through electronic trading or through broker dealers. It's very hard to get a handle on exactly what is the fixed income market, what's trading where and when. And so that's why yet another way in which fixed income kind of helps is we have subscriptions to those primary data sources so that we take that burden off of our customers. They don't have to pay for these expensive data subscriptions just to get the raw transaction data for fixed income markets. We have data beyond the corporate bond market, but we're primarily focused on the high grade corporate bond market right now.
Nice. And then in data science, I'd love to hear your input there too, where you think, because we always talk about or hear about this journey or this evolution that's taking place, but depending on where you are in the market, there's all different roadblocks, right?
Yeah, I mean, we could spend a long time talking about this, and I've thought about it a lot myself. I think if we could, very, very high level, I think striking that balance to me is an important way for us to just move things forward, because I think there's a lot of talk and there's a lot of hype. There's a lot of claims out there. There's people that have made some great achievements in certain areas, doing certain things. But as a whole, I don't know that we have struck a balance really yet between theory and practice. What can we do? Where should we be going? Where should we set our goals? I think a lot of this really comes back to depth of understanding and training. I really do. I mean, and that goes on both sides, right? It's not just about racking up degrees and certifications, but it's looking at things more deeply and from a holistic perspective. I like to use physics as a discipline that's a little bit more mature, or maybe perhaps much more mature than data science, to shine some light on us and to help us direct where we should, how to think about things and how to move things forward. But if you look at physics, it's a rich blend of theory and practice, right? And it has been for decades. And I think that's why it's been so successful, because it's nice to pose, to do cool math and pose deep theoretical formulations like string theory for how things work and how the universe behaves. But those things have to be held accountable at the end of the day. And that's why we have experiment, and that's why we have practical disciplines, right? And so that's the way I tend to think about data science. We need both the theory and the practice. And it's not a question of, is Python better than R? I see a lot of these things. To me, honestly, that doesn't make a lot of sense, right? Those are just the tools in your toolkit. And it's not so much about, is it better to have 20 years industry experience or 10 years of graduate school? No, not really. It's about striking the balance, right? Because those things complement each other. And if we can look at things from a more holistic perspective, I think that's where the depth of insight comes and understanding come from.
Yeah, I think that holistic concept's interesting. We hear a lot about the domain expertise, right? The combination of domain expertise and then data science or mathematics and engineering. I think of it in terms, you said physics, I think sometimes in terms of like engineering versus material science, right? Because engineers are great. They can design a bridge and and from a mathematical perspective, it can be perfect. But when you get into it, you have to understand the materials, the nature of the materials, because just understanding what, the breaking point is and some of these things is great, but there's the practical sense of like, what are you actually going to use, or what's practical to use, both cost and time and labor, everything else. So now we're getting into the world of data science that, as you said, like we've got to go beyond the theory, but we have to understand the domain expertise. We have to understand what we're actually trying to accomplish, right?
Yeah, one of my favorite questions, I've interviewed a lot of junior quants over the years. One of the questions I love to ask is, tell me about a project you've worked on, and someone will tell me, yeah, I use this state-of-the-art package that does blah, 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 and deep learning and whatnot. And I'll say, well, okay, if I were to take away those packages from you, could you do the same project? And I immediately see sweat pouring on people's heads, because one of the favorite things I like to ask about are just real fundamental concepts like ordinary least squares regression or logistic regression, or like if I were to take away that OLS package, could you write me a function or a routine to find for me the beta coefficients for OLS? Most people just don't know where it comes from, have no idea, right? In neural networks, it's math under the hood, right? It's a lot of matrix, multivariable calculus, matrix calculus, chain rule, and whatnot, and a lot of numerical methods and numerical analysis to come up with solutions that converge, linear algebra, things like that. But there's really no escaping those fundamentals in my mind. And so you may be using these cool packages, but how do they work? Do you know what's going on under the hood? If you're using some type of non-parametric method, what are the techniques they use for determining those kernel functions, right? What kind of statistical tests do people use to assess significance. When do they work? When do they not work? So, you can do cool stuff, but you can fool yourself into thinking that you've done something that's a lot more robust and rigorous than what it actually is.
Yeah, I mean, a lot of that's so important around sort of benchmarking and really understanding the fit, the model fit, and reviewing it constantly. That's the part that people, oh, we figured it out, it's off and running, and it's like, that's great, but there's drift, there's all sorts of things happening, and you have to really understand what's going on, so when you need to refresh the model or retrain, do other things.
Credit is a good example of this. A lot of my colleagues work in credit default space, and I used to work in credit derivatives desk for Goldman Sachs as well back in the day. But in credit, you have a very imbalanced data set. Defaults are just 1 or 2% of your data, so you can really fool yourself into thinking, "Hey, this model works great."
Yeah, and it's just outliers. You're just picking the outliers.
Yeah, like you mentioned, black swans. You got to be really, these things can rock you, especially if you're a hedge fund and you're working on leveraged capital. I mean, forgetting the name of it now, but yeah, back in the 2000s, it starts with an L. I'm forgetting the name of that company, but they'd made a lot of leveraged bets and on leveraged capital, and a lot of these outlier events that are never supposed to happen. When they happen, and typically when markets are distressed, really distressed, correlations go through the roof. Everything becomes either very strongly positive or negatively correlated. And models just don't capture that. We just don't see that in our data, historical data, unless it's really like some kind of global crisis. But it only takes one of those things to wipe a company out, like Lehman Brothers, right? Or a hedge fund or a stat arb fund. So you can test and test and test and say, I can withstand six sigmas of market shock, but yes and no, because what is that? That's just like we said, you're not really looking at the whole distribution yet. You don't really know what it is almost by definition.
Yeah.
And it only takes one of those events to knock you out. This is something I learned. I think first derivatives class I took from when I joined Goldman almost 20 years ago, and somebody showed me a chart, and he had like a pop quiz. If I told you the futures price for oil today is $80 and it goes up to $100, in 3 months, would you buy that contract? And most people raised their hand and said yes if they're long the contract. And then on the next slide, the guy says, oh, but tomorrow it's going to drop to $20. And now you're going to have a margin call from that drop to 80 to 20. You'll be out of, unless you've got a lot of capital, you're out.
Yeah. I think also the behavioral side, you've got these outlier events and the data says something, but depending on what the actual event is, like with COVID, you have these situations like fear is very hard to model, and you have fear in the individuals doing the trades or on one side or the other of the transaction. And we saw this like in the housing market and all sorts of markets where all of a sudden everyone just paused. And it wasn't that there was anything wrong with the market per se. It's that everyone's kind of like, okay, let's wait and see what happens. And then for all we knew, the market could have gone the opposite direction,
Yeah, it's interesting you mentioned those social factors. I think they're underestimated. On a relative basis, I would say that fixed income trades on a more technical basis than the equity market. The equity market factors in a lot more emotion and fear and psychology and things like that. But to the end of the day, you've still got humans making decisions anyway. Not everything is algorithm driven. And so that absolutely impacts the market. And I don't know of too many models that really explicitly incorporate those social factors that you pointed out.
Yeah, I mean, I see things trying to predict that, using things like Twitter and social media to sort of like understand what's going on, but it's usually disconnected from the other data sets. So it's really hard to sort of combine them and really understand holistically what the picture looks like.
Right. And so the supply chain is a great example if you think about it. Like it's always in the news, like there's all types of supply chain risks. Are we going to have the products we need for Christmas and Thanksgiving and things like that? But part of it is, like you said, a lot of it, and there's a lot of interest in causality in machine learning too. What drives what? You know what I mean? It's like you said, and you've got these butterfly effects that are happening. And if some ship blocks a canal somewhere in South America, right, all of a sudden that impacts oil prices here. So there's a lot of interesting dynamics going on there.
Yeah. So I'd love to hear from you, your view of kind of looking into the future. where do you see sort of data and data modeling in the fixed income space? Like just looking into the future, how do you see it evolving over the coming years?
Yeah, I really think electronic trading and machine learning and algorithmic trading are just going to come more to the forefront. Back in the day, 20 plus years ago, when I used when I used to sit on the trading floor, a lot of it is human driven, like, people making big bets, taking big bets can really move the market. These days, I don't know that that's the case. There's so much algo trading and so much transaction volume that's electronic. I expect that to continue. And so I think it'll be algos versus algos, actually, if I think about what the future is probably going to look like. And there'll be the human element comes in reviewing and assessing the quality of those algorithms. But at some point, I don't know that it'll be human beings trading. I don't know when that will be, but.
Do you think that changes the sort of the value side, meaning the ability to generate, outperformance, right? Because you're competing on almost like a commoditized sort of mathematical method.
Yeah, I mean, it's alphas against alphas, right? Or I don't know, there's a Greek letter above alpha, but it'll be interesting to see. I wish I had a crystal ball and can say, but I think there are some results in theoretical machine learning that says that one algorithm cannot consistently beat all other algorithms under certain conditions. So it's very hard to come up with the quote super algorithm that's always going to dominate every other algorithm in all circumstances, all situations. So there's going to be pockets where one algorithm beats another and vice versa, invariably, almost by definition. So I think that's likely to be the case. It's just our human nature. We have differences, right? And so we don't all see things the same way. It's remarkable. Psychological tests can show that. Some people see glass half empty, half full. So I don't think it'll be the end of things. I don't think there's a master algorithm out there. I think what will happen is different types of investors with different risk and reward preferences will favor different classes of algorithms over others. So the market will still be competitive. It's just humans will be removed one level from doing the actual execution and making those investment decisions. That's my view anyway.
Yeah, and once you get true learning algorithms out there, then they're going to start to sort of chum the water for the other algorithms, right? They're going to purposely do trades and transactions to to make the other algorithms do certain things so that they can take advantage of it, right?
Yeah, it all becomes like how do I say it? Like, I've moved to Tampa now. I'm spoiled now because we just won the Super Bowl, right? Because of Tom Brady. And so my expectations rise, right? And so it's for this year. And so it's kind of like that. Financial markets are like that. Once you have algorithms that can, quote, achieve a certain level of return and performance and consistency, that just becomes the new bar. Like I said, alpha on top of alpha.
Nice. So I'd love to hear from you. What type of guidance or advice would you give to someone who's interested in sort of a similar role that you have today, and looking at your career path? What kind of input would you give to someone?
Yeah, I mean, I think the first thing I would say though is to really, it can be tempting when you just graduate with a degree to say, hey, I need to get a job. The market is hot, but try to resist that and strengthen your training as much as you can within reason before you hit the job market. Because once you start working, it's very hard. Your opportunity cost changes dramatically, right? When you're in grad school, you're on a stipend, you may have loans, but you may have some grants. And so the opportunity cost of 6 months to 1 year is not too bad. But the minute you start working, you see it in real dollars now. And, depending on where you are in your personal life, it really matters for your family, right? Your living situation and whatnot. So the penalty function, if you will, is less severe when you're still in school. It becomes more severe when you start working. And so I guess my number one rule would be really try to strengthen your fundamentals as much as you can before you hit the industry. Having said that, like I said before, I view it as a lifelong process learning. So always stay fresh, always challenge yourself. Like you said, there's areas of domain expertise. So I may be great in one thing or strong in one area, but weak in another. So let me work on those areas. Let me talk to my colleagues. There's tremendous amount of knowledge and experience on the team. The first place you can leverage really is your direct manager and your teammates that may have knowledge in other areas which we don't, and we can learn from them.
Yeah, it's interesting. You know, we hear so much nowadays. There's a huge demand for people with data science, mathematical, quantitative backgrounds, but a lot of them don't have the fit of where they're, you know, as far as their training and expertise, they just don't have enough of the skills quite yet to fit the role. So, so that's really good advice. And there's tons of sort of training and academic opportunities out there, and there's a lot of companies that'll pay for that too, even if you're not working for them at the time, right?
Yeah, no, that's great. That's an exciting new trend that I'm seeing is companies really helping foot the bill and help encourage their employees to develop and continue to grow. I think that's a great idea, and it's going to pay big dividends as well. And I'm actually recently dipping my feet into the teaching waters as well. I'll be an adjunct professor at the University of South Florida starting this spring. I'll be teaching a course in robust optimization to the PhD students there. So I
Oh,
would like
nice.
to do my part to contribute to teaching in graduate programs as well.
Oh, that's great. Um, well, we at the Data Standard are building a community of data enthusiasts and data thought leaders. Everyone is open for collaboration and to connect with one another. What can the community do for you? You know, what types of things are you looking for, networking or collaboration opportunities?
No, it's good that you mentioned that. I mean, I think as I hopefully do some more discussions and have a few more of these conversations on this data standard, just helping to market that. It's good for my own profile, but it's also good for the firm as well. But it'll help show that we're making a difference and participating in the larger data science community. So those things are nice. I always like to network. Like I said, I'm kind of fascinated in some ways by things that I know the least or know less about. I try to learn more about. Like you said, like we were saying, I think there's so much to learn from other people, both on the theory side and the practice side. And I try to stay humble, and I try to stay open, and I try to learn from others and see how I can improve and do better based on, you know, what I learned from other people, really.
Well, thank you. So we really appreciate your time, and it's great that you were able to join us. Where can the community find you? What's the best place to connect with you?
Yeah, LinkedIn is probably the best place, Gideon. You know, I'm on there naturally a lot. I think I have a reasonably large following on LinkedIn and connections both in industry and academia. That's probably the easiest place to find me. Starting there anyway. Yeah.
Okay, great. Well, I'll have the team put your LinkedIn profile in so people can easily find you. And, you know, thanks so much for joining us today. And if anyone would like to get more information on the data standard, you can visit datastandard.io. And once again, thanks so much for joining us, Derek.
Thanks, Gideon. Have a good one.
You too.
Bye.